All right guys, welcome back to the channel. For today's video, we're gonna be tuning on this 2012 GMC Sierra Denali. This truck has a stock bottom end 6.2, but it has been upgraded with a camshaft and a D1SC Procharger. I wanna do this video because a lot of guys mess up the tuning process on these. So when you have a heavy vehicle with pump gas, stock bottom end, stock trans with boost, it sounds like it may be easy to tune, but it's actually can be kind of tricky. So we're gonna go over the process of doing this the correct way. So let's go ahead on and get this thing inside and get it up on the rack and look it over. All right, so let's go ahead on and get the hood up on this truck. So what you're looking at is a stock bottom end 6.2. This is the original engine to this 12 model Denali. So this truck would have had variable valve timing and it would have had a AFM/DOD on this. So all that's been removed. The shop had already done a BTR stage 2 LS3 car camshaft. So this is not the truck cam. So this is a little bit more rowdy than what you're used to seeing. It's also got the 300 millimeter Circle D inverter. I believe this one's the 3000 to 3200. Cruised it like that for a little bit, wanted more power. So brought it back to the shop. Shop installed a D1SC Procharger, which I said D1X earlier, but it is a D1SC. So anyway, so when you're starting the tuning process on one of these, you want to go over all your vitals. So for reference, we already know mass airflow sensors here. This is like a 3.5 inch pipe. And let's pull this cover up. All right, so because I do know the shop that put this truck together, I do know a lot of the vitals, but you're always gonna wanna check this for yourself. We've got the red label CTS-V map sensor. We have a set of DECA 80 injectors. I do know this truck has a fresh set of BR7 EF plugs in it that are gapped for boost. So that's kind of the vitals that we need to look for. They've already smoke tested it, made sure everything was good. So this truck is mechanically sound. So that's always a blessing for me. What I'm gonna do with this truck is, because of the MAF location, more than likely the truck's not gonna drive the greatest in MAF mode. So we're probably gonna end up on a 2-bar OS and speed density. I'm going to try, I will tune the MAF sensor also, and we'll try to run it in MAF to see if it actually is happy that way. But regardless, we'll have a 2-bar V table set up on it as well. So let's go ahead and get this thing up on the 4-post and look underneath it and make sure everything looks good underneath. So the first thing you're gonna notice is the PROCHARGER intercooler and how they do this. This works. It is not my favorite design. So this is one of those things where it basically is relying on this little splash guard. So obviously this is just gonna catch air and force it up into this. So this is a lowered truck. I don't know if you guys caught that earlier, but it is lowered. So I don't like this design, especially because this is a 12 model, so it has the opening in the bumper. So I really feel like if there was a way that they could have put the intercooler right there, that would have been better. But regardless, the boost level this thing's at, it should be fine. So as we look further, tires are good. A little bit of water under here, but I think that's just from where it has been raining. Engine itself looks clean. So that looks good. Man, it looks really clean under here. I always like to see. So we've got the X pipe, got the True Duals on it with the larger mufflers. This truck actually sounds pretty good. Rear tires are good. Don't feel like slopping the rear U-joint. Don't feel like slopping the front. So I'm gonna check the motor mount as well. From here, it looks like it's been replaced. But anyways, let me get the wideband in it and we'll get it on the dyno. All right guys, so we got the Denali up on the dyno, and first and foremost, before anybody says anything, if you didn't catch it when we did our under the truck video, this truck is 2-wheel drive. I know it's rare. You may or may not even have seen one of these. I've actually tuned several of these on this dyno specifically, actually. Today's gonna be a video that's gonna be a little bit more long-winded than normal. I know my videos are already kind of long-winded, but apparently you guys enjoy it. So this truck it's a common platform that a lot of tuners get wrong. And the reason why they get it wrong is because they don't tune it accordingly to the gear ratio, what the vehicle's going to do, the weight of the vehicle, etc. when it comes to ignition timing and commanded air fuel ratio specifically. So we're going to go over that in this video. Another thing we're going to do is I actually read out the fuel pump control module in this vehicle. And I'm doing that because this truck has a Walbro, I believe it's either a 525 or a 535. We've got a tune for an aftermarket fuel pump in the tank. So that is one thing that we need to work on as well, because this vehicle is a returnless vehicle. So it uses the pulse width modulation of the fuel pump. And if you don't know what that is, basically what GM does, or a lot of manufacturers do with pulse width control module, is they actually turn on and off the fuel pump to maintain fuel pressure. So what happens, these trucks do have a PID system, which we discussed in other videos, a PID system on controlling fuel pressure. But if you want this truck to actually run correctly and always have the correct amount of fuel pressure whenever you're going to make that hit, it's always best to tune the fuel pump control module. So yes, it does cost an extra $50 for the extra credit. So this truck's going to take 3 credits to tune. But that $50 is so worth it to actually get this fuel pump control module dialed in. So what I'm going to do is I've already built a base file for this truck. This truck has already started, drove, and moved around. But I'd already tuned this truck before when it was just natural aspirated. So literally all I did was just change the map sensor and I put in the injector data and I let it go. So now that the truck's here, we're going to dial this thing in properly. So again, I'm going to cram a lot of information in this video. So if you haven't already, please subscribe, because this is probably going to turn into a 2-part video. Like, I'm going to film it all today. It's probably going to turn into a 2-part video, really more so just to keep the actual time of the video down and to give me a little bit more time to edit. So it's much easier to edit 2 videos over a couple days versus 1 big ass video in 1 day. All right, so what I'm going to do though is I'm going to go ahead on and set up my scanner and make sure I'm logging the correct channels. And I want to go ahead on and dial in the fuel pump control module first, or at least get it in the ballpark. So I'll show you guys, it's a pretty simple step. So I'm going to go ahead and get that stuff set up off camera, but I'll show you how I do it. It's going to take me a few minutes, so I'm going to go and shut the camera off, but I'll be right back. All right, guys. So first thing we're going to do is when we're tuning our fuel pump control module, we have to look up our fuel pump trims. So what we're going to do is you're going to right click, you're going to go to add channel, and you can just type in fuel pump, and you'll see that we have short-term trims, long-term trims, commanded DC. So you're going to need to log those. So the next thing you're going to need to log is you're going to need to log instantaneous fuel flow. So you'll see instantaneous fuel flow estimate. And again, if you're not paying attention, you can search the search bar in the channel selector, but you want to double click it and then it'll show up blue once you actually got it logging. You're going to need to look up fuel pressure. So you'll just search for fuel pressure. We're going to actually log fuel pressure requested and fuel pressure itself. Any of these will be fine. But you'll see this fuel pressure SAE is a good one, and then fuel pressure requested is what you're going to want. So let's go ahead and get the truck started. We're going to get the scanner up and going. Well, basically what we're going to do is we're just going to build a graph to graph out our fuel pump control module settings. So in order to do that, you're going to need to pull up your tune file, and you're going to need to go under fuel system, fuel control module, and we're going to look at open loop DC. So this is essentially right here, this is our table for controlling basically the amount of time that the ECU is turning on and off the pump. So the top axis is fuel pressure. This is fuel flow rate. So this is that instantaneous fuel flow rate that we were talking about. And this blower is like, it's loud. I don't know if y'all can hear it on video, but she's a screamer. All right, so to make your graph, all you gotta do is you can just click right here, right click. Now, obviously I have mine already set up, but right click, graphs layout. You would hit this plus button to add a graph. Click that, hit add table. And then the parameter, what we're gonna do is, let's just do fuel pump short trims. We'll just type in fuel pump. All right, so you're gonna pull up fuel pump trim short term. So you're just gonna double click that. Fuel pump control module is what I call it. So column axis is gonna be fuel pressure. So you just click column axis, put in fuel pressure. So we got fuel pressure, SAE. Yes, sounds good. We're gonna change the unit over to KPA. And then what we can do is we're gonna go back to our table and we're gonna right click and you're gonna go down to column axis and copy labels. And then we're going to paste that into here. And then row axis is going to be our instantaneous fuel flow. And this one is in pound per hour, so that matches. Then we're going to right click, row axis, copy labels. All right, and there's our table set up. So this one is the one we just built. Now that you guys have that, and I will tell you guys, if you're a member, so there's always a members only link in my channel. Now, I haven't been putting out as many members only videos as what I want to, but I do obviously give my members my email so they can ask me. Like I have a ton of guys ask me for different versions of Excel sheets they see me use on the videos, things like that. So if you're a member and you want a channels config of what I use on Gen 4 stuff, you can just literally just email me and I'll shoot you over this channels config. Just make sure you put in the subject, you know, members, channel config, or whatever. Just let me know that you're a member and I'll shoot it over to you. So anyways, I'm gonna go ahead on and I'm gonna right click and I'm just gonna remove the table that we just built because obviously I already have one. Right now, if you guys will look, I've got fuel pump trim long term, it's at 1.30. So that means that for whatever reason, the ECU is commanding 30% more to run this pump. To be honest, I don't really know why. I guess I need to plug in my wideband. My wideband is just sitting here without 12 volts going to it. If y'all are wondering, I use a Ballinger AFR V2 wideband, and I just put like a 12 volt outlet round connector on there and just plug it in that way. But anyways, so you guys will see our fuel pump trim is 1.30. So this is a long-term trim. So what I always do is I'll take the long-term trim first, and I'm just gonna take this and you just type in that exact multiplier. So 1.30. And that right there is going to instantly bring up what the ECU has been looking for. So we're going to do that, and then I'm also going to do that in minimum duty cycle. All right, so long-term trims are handled. Now, this is just me roughing this in. So you guys will see that once I flash the fuel pump control module, it's going to reset the fuel pump trims, and that's when we're going to start to see the short-term trims. So when you're actually building this data, if you want to build a table, like a math parameter to add both short-term and long-term together, you're more than welcome to. Traditionally, I'm on a dyno, so I'm doing steady state stuff. So usually I don't run the vehicle long enough to actually have a long-term pump trim. So I'm just showing you my way. You guys can do it your way. I will take that 1.30, go over the whole table, and then I'm gonna shut off the data logger and I'm gonna load this in. And so all I've gotta do is I'm going to go to my tune file. I'm gonna click the red arrow, and I gotta buy a credit for it. I forgot I haven't licensed this yet. So if you don't know how to do this, you just click show license options. You can click purchase credits online and it'll pull up your account. Obviously I'm not gonna let it pull up my account on here, but I'm gonna go ahead on and buy a credit and then I will be right back. All right, so credit's been purchased. If you guys haven't done this before, just go to help resync interface. It'll read the interface, it'll add your credit and you're good to go. All right, so now that the credit's been added, we're gonna go ahead on and license it. All right, so we're just gonna click specific, click OK, yes. And now I'm gonna write the file into the fuel pump control module. All right, so I just wanna write that in. So I'm just gonna click do not write on the other ones and we're gonna go in and write this in. Now, obviously the optimal way for you guys would be to, like I said, if you wanna do a math parameter to where you're actually doing long-term plus short-term, you can. Or if you just want to do it my way, you can. You could also do two graphs if you want, where one's long-term and one's short-term. And if you just want to just tune it with long-terms, you can. There's so many different ways of doing this. I'm just showing you guys the way that I do it. So now that that's loaded in, just go on and start the truck. All right, so now you'll see long-term trims actually didn't reset, which is kind of strange. Usually these will. You'll see where short-term trims is pulling it back out. So it's kind of strange that it didn't reset fuel pump control module. I don't think this one has a way for me to reset it either. Oh, well, while the truck is running, maybe it'll learn the fuel pump trim back down. That one's kind of new to me, but I also, traditionally on a vehicle like this, usually we'll go on and go return style fuel system on here, and I usually don't even have to do anything with the fuel pump control module. But anyways, you guys see the process though. So you guys saw where I added the 30% and now it's pulling back out. I mean, it's 0.77 multiplier, so it's pulling back out, was at 23%. So I'm just gonna let everything calm down. So as you guys can see, V table is a little bit off compared to MAF. I don't even know what this truck is actually running on right now. I may have set the speed density. No, it's on the MAF right now. Okay, so looks like we got to work on the V table some. MAF table was surprisingly close, which is cool. Because I don't think I changed this. I may have. It's just, again, it's hard for me to remember. All right, anyways, now the fuel pump control module is going to be more so in the ballpark. We're going to go in and stop the data logger, and I need to go in and pull up the actual tune file for this truck, and we need to go over it and see what we've got as far as make sure map sensors are set up correctly, make sure injectors are set up correctly, make sure all that stuff is set up. So let's go in and dive into that. All right, so I got the tune file pulled up, and what I want to do is, because this thing is PROCHARGED, let's go ahead on and get this thing over into a 2-bar operating system. So first we got to make sure that there is one available. So if you want to do that, you just click OS, and sure enough, right here, we got speed density 2-bar. So we're going to apply code modification, and then what I'm going to do is I'm going to go to File, Save As. I'll save it as the file name that I want. And then what you have to do in order to see the tables, you got to close the file out and then pull it back up. All right, so now that we've got that, what this has done is this has made it to where we can adjust cooling fan temps even lower. So if you guys have ever seen a factory cooling fan temp table, you go under System, Fans, Control by Percentage. This axis is actually locked to where you can't change it. So from the factory, this would have been 192 and it would have gone up from there. Now it actually starts at 163. So now if we want to have the fans off at this time, we can just hit 0. The fans are pulse width modulated, so they're the on-off thing again. So this is the percentage that the fans are on. So just for right now, let's do this. Let's say 20, 40, 60, 80, and we'll be on full by 195. I've got to verify what thermostat's in this truck, so this is just something just generic for me to show you. It's also added V tables. And now I don't know if you guys have seen my other video on doing 2-bar. I think it was my very first video where I did like a vlog where I was tuning on the, I think I talked about it when I was tuning on a Corvette. But anyways, I'll show you how to do this. So under airflow, general, you've actually got a legitimate VE table here. So if you go under edit, there is no more virtual volumetric efficiency table up here anymore. Now, just because we've done a 2-bar operating system, we can still operate on our mass airflow sensor 100%. So I'm gonna want to do this on 2-bar because the 2-bar operating system offers me other stuff like under power enrichment, fuel, power enrich, we actually have an EQ ratio versus map table now. So that way, the more boost that we have, the richer we can command the vehicle. Some guys won't utilize this. Some guys will just go under power enrichment right here and they'll just make this whatever they want. But to me, I like to use this one. So you'll see any of the 2-bar operating system stuff is not gonna be filled out right now. So that's why the V table is zeroed. That's why the EQ ratio right now is at 1. So just stuff like that, we have to fill out our own information. Another thing that's cool on this one is, say you got a turbo vehicle, you can actually go under fuel cutoff and you can actually do a boost fuel cut. So say this truck only has enough fuel for 180 kPa and I'm worried that the owner is gonna pulley it down. I can literally just go in here, get fuel cut, enable, and when I say like 180, yeah. I can just have it like that to where if it goes over 180, shuts the truck off. So then the customer's gonna call me and wonder, well, hey, what's going on? And it's gonna be like, what'd you change? Oh, I pulleyed it. And that'll let me know, hey, we gotta get this thing redialed in for the new pulley. I don't need that on this. This is obviously a ProCharged vehicle and it's on pump gas. I don't think the owner is going to pulley this truck, and if he does, I'll just make sure to let him know that, hey, you can't really run much more than what this truck's got on pump gas, in my opinion. Anyway, so 2-bar operating system is really cool, but if you need to figure out how to actually fill this in, then that's what I'm going to show you. So what we can do is I'm going to pull up the tune file from this truck from the naturally aspirated tune file. All right, so right now I have the NA tune file that I had in this truck, and I can go under edit, pull up virtual VE table. And this right here is the V table that I ended up with last time. Now again, this truck I just remote tuned, but I think I got this pretty damn close. So anyways, all you gotta do is, it's pretty simple. So you can actually go under, this is the 2-bar operating system. This is our tune file that we're gonna be loading into this truck. And what we can do is we can actually click this, we can right click and hit view inverted. Now you may ask, why did I just do that? Well, because our volumetric efficiency table, our virtual VE, is engine speed up top, map on the side, and now this table matches. Whereas before, when we first did the 2-bar operating system, map was up top and RPM was on the side. So now this matches. So what I want to do is I want to make sure that the RPM is what I like. It's 400 to 6,800 this truck. Yeah, that's perfect VE table for this truck. So what I'm going to do is I'm going to copy label from up top and we're going to paste this into our virtual VE table. Now, one thing you guys have to understand is that because of how HPtuners calculates the coefficient, we can basically infinitely change the axis on our virtual VE table, and it will automatically adjust our VE table to where it matches the axis correctly. So then the next thing what we're gonna do is I wanna have this truck to where map is actually like, makes sense, you know, for our truck. This truck, with it being a D1SC, I think the pulley was like, I don't know, 4.5 inch or something. But anyways, this truck shouldn't see more than like 10 pounds. So I'm just gonna look through right here and make sure that this table is actually pretty close. It is. So what we're gonna do is I'm gonna go up to 180 kPa. So right now this is just a 175. And this truck honestly is not gonna need a 15 kPa row because it has a pretty big camshaft in here. So I'm just gonna add 5 kPa to this whole row. And now that'll cover us to 180. And 180 I feel like is gonna be a good, I think it'll be good for us. Next thing we're gonna do is we're gonna right click. We're gonna hit row axis. We're gonna hit copy labels. And now we're gonna do the same thing for right here. So we're gonna paste this in and it is gonna change up our VE table. Now, because it just did that, if you notice, now we've got crazy negative numbers down here. Well, that's because we never actually factored in on our virtual VE for boost. In my opinion, the easiest way of doing this is just gonna be take your 100 kPa row. We're gonna copy it. We're gonna paste it into the 180. And let's just add, this truck is returnless, so let's just add 20% to this table. It's probably gonna be too much, but we just want to build a table. So we're going to go from 100 kPa down to 180. We're just going to interpolate vertically. And this is what our VE table looks like now. So you can kind of see where the 100 kPa row was. If you want to, you can smooth it out or do whatever you want to do. So we can just take this and we can just hit smooth vertically, kind of dress it up and make it look like what a VE table should. So again, right now we're actually modifying the NA tune file for this truck. This is not even the tune file that we're putting into this. So that's where this comes in. So all we got to do is we're going to copy this whole table. I'm not going to worry about calculating coefficients because again, we're not tuning on this tune file. We're just using this as essentially a way of inputting into our VE tables. So we're going to copy this table. We're going to go back to our 2-bar operating system and we're just going to paste this in. So now we actually have our legitimate V table ready to go. And then all we've got to do to convert it back over to the 2-bar, or how it was originally, is we just right click, uncheck view inverted. And now this is back to normal. And this now matches up, so you'll see it sideways. And now this now matches up to the other tables that we have. So we can just copy this, go to normal IMRC open, paste it in. Now again, as I told you guys, I always do this stuff in a uniform manner. Right here, I just did it under VEDOD. We know that table's not gonna be active. I just put it in anyways. All right, so I'm gonna go ahead on and close this one back out. No, we don't need to worry about changing any of that. We're just gonna close it out. All right, so now we have a legitimate V table in our 2-bar operating system. One thing I will tell you from experience, this charge temp multi-table, some vehicles, it works really good to fill this in, some it doesn't. What I have personally noticed on the trucks is that the trucks seem to like the injector modifier better than this table. So I'm actually gonna leave this as a 1.0 multiplier in this specific application. Now there's applications that I've, like turbo Corvettes, where it seems like it likes this charge temp multi to be filled in. But in applications like this, for whatever reason, I usually have better luck going under the fuel, general, and this fuel flow rate versus IAT multi. And then I've showed you guys this before. I'll actually take like a ZR1 or LSA tune, put it in the background, and I'll just copy it straight over from there. And it actually usually works pretty damn close. So I will be doing that as well. Now we've got a good V table in this truck. So we're gonna go over everything else and make sure, okay, idle stuff, we're not gonna have to mess with it right now. Airflow, I wanna go ahead on and put this truck into speed density. So I'm just gonna make this an 8, make this a 7. We're gonna go under engine diag, go under airflow. We're gonna make this top number, just we'll call it a 10. We'll call this a 1. And then we're gonna go under DTCs. And now again, this is just for the tuning process. This is not how the truck's gonna be left. We're gonna put this on MIL first air for mass airflow sensor. And then the final step to make this truck, this is the one that gets a lot of guys, is go under idle, airflow, and this effective area max min. So this max fail, min fail is for when the mass airflow sensor is failed. And so I'll have a lot of guys that'll try to do 2-bar speed density on these trucks, and they'll have it to where cold start is like garbage, and the truck won't even really start. All you gotta do is just copy these numbers down. So we'll make this 8191. Make this 0, and now this truck is going to be in speed density. So I'm going to save this as, so I'm going to go ahead on and send this in. Now in order to send in a 2-bar operating system, you have to write this entire. So you would definitely want to make sure the battery is up good. You also want to make sure that your auto headlights are disabled. We're not worried about the trans right now, and we're not worried about the fuel pump control module. So we're going to go under this engine operating system. We're going to change this to write entire, and we're just going to load this in like this. The write entire process is a longer process. It'll probably take it 5 or 6 minutes to get it wrote in. So anyways, I'm gonna send this in and we'll be right back. All right guys, so tune file is loaded in. We've got the 2-bar in there. So again, the truck's right now running on speed density. I want to address some things that you guys have emailed me or commented about. So first off, I don't plan on ever offering a tuning course. I'm a professional tuner. So, you know, a lot of guys that I've noticed, now this is just a generic statement, but a lot of tuners that I know that offer courses only offer courses because they really maybe didn't work out for them as good when it comes to professional tuning. Obviously that's not the case for me. I do this stuff all day, every day. So that's one of the reasons why I can't get out videos as often as I would like sometimes, is just because like I'm doing this all the time. So if you would like some references on how to learn how to tune, Greg Banish has some tuning DVDs on, I think you can get them off of Summit Racing if they're still available. Get on Summit Racing, type in, the name of the business is called Calibrated Success or Greg Banish. Try to find those DVDs. If you can't, I will tell you that the major places that teach tuning tune you incorrectly, which we've gone over in other videos, majority of them. Now I have heard some good things about Evans. So if you'd like, Evans got an academy. I think that you can pay him like $50 a month or so and learn how to tune. I haven't personally used that. I'm just going off of what other people have told me. I have also been told about the Elite Tuned, that maybe it's decent. I don't know again. But again, I'm not offering tuning courses. I'm gonna bring you guys my videos. This is literally just me putting this out here because I want to keep tuning going for the future generation. But when it comes to doing the step-by-step stuff of making courses, I honestly just don't have time. And it's not because I don't have physical time, it's just because I don't personally want to make the time. I enjoy having, you know, time with my son and going on vacations and things like that, you know, I want to spend family time where I don't really care about, you know, making additional money on building a tuning course for you guys. It's unfortunate, and who knows, maybe once I get older, when I'm not doing this professionally, maybe I will. But right now I'm just trying to fulfill my duties as being a professional tuner, but also getting this information out here, because the information that I'm offering hopefully is helping even some of you guys that are actual professional tuners yourselves, that I'm just showing you guys stuff that I deal with on a daily basis. So it's stuff that a lot of the books don't cover this stuff. I don't think any of the books cover 2-bar operating systems and how to input your V tables and how to properly scale injectors. Like there's a lot of stuff that you guys will find this information on my channel. Silver Surfer is another good one to watch on YouTube. I'm trying to think, I don't know of any other good YouTubers when it comes to teaching tuning. HPtuners forums, some of the Facebook pages, a lot of the Facebook pages now, guys have just become dickheads where they're just trying to get your money on remote tunes. So they'll tell you drop a file and drop a log, and then you do that, and then instead of them helping you, they're like, we just need a remote tuning, and then you'll see these comments of PM me, I can remote tune. It's most of these guys that are, when they pretty much whenever they say PM me, they're not actual tuners. These are guys that don't do this professionally, or if they do, they probably don't have any idea what they're doing. And if you guys are on the Facebook pages and you're putting out the PM me on everybody talking about remote tuning, and you're watching my videos, like, I'm sorry, I don't mean to offend you, but just majority of those guys just don't know what the hell they're doing. I get so many emails a day. So that's another thing, you guys, you know, I do have my remote tuning email in the description. I will tell you guys, first and foremost, I don't tune any Chinese throttle bodies, like drive-by cable stuff. I really don't tune drive-by cable stuff for anybody other than shops. I'll do all the drive-by-wire stuff, Gen 4, Gen 5, all that stuff. So if you guys want to email me, you can. But a lot of you guys are also emailing me about stuff that's not related to remote tuning. And I don't mind sometimes, but you have to understand that if I don't get back with you, if you've emailed me something that is off topic and I don't get back to you, please don't take offense to that. The free information that I want to give is going to come out in my content. So going on to a personal one-on-one email chain that's making me $0, sometimes I'll do it if I have free time and I'm bored. But for the most part, if I'm working, I'm trying to make money. So you guys have to understand that. And anyways, rants over. Normally I go on these rants like my members only videos, but again, not trying to be a dickhead, just trying to shoot everybody straight. Anyways, truck's up to temperature now. We are in speed density only. I haven't even glanced at fuel trims yet. Looks like we're showing a little bit rich, nothing crazy. Wideband's looking okay. Everything's looking okay so far. So let's go ahead on and drive this thing. I've already pulled the ABS fuse. If you are unaware, most 09 and newer trucks, we'll go specifically 09 to 13. There's a green 40 amp ABS fuse that traditionally needs to be pulled under the hood for dyno usage. It also needs to be pulled under the hood. If you're gonna make a drag strip pass in one of these trucks, pushing and holding the traction control button down till the StabiliTrak is off only works up to a certain mile per hour. So if you're making big power and you wanna make a drag strip pass, just pull that 40 amp fuse or unplug one of the front wheel speed sensors. Same with running at the sand dunes. I had a Yukon this body style, took it to the sand dunes. Even in 4 low, the truck would still shut the throttle and it'd still pulse ABS. Pulled that fuse, she was a ripper after that. So hopefully that helps you guys. But anyways, let's go ahead on and get this thing moving. So it looks like I'm pretty damn rich. The NA part of this V table I built when it still had the factory injectors in it and it wasn't PROCHARGED. The PROCHARGER doesn't affect the down low VE as much. Now you are getting some airflow coming in, so it does alter it slightly, but the biggest difference is going to be the injector change. So I'm just driving the truck right now, just kind of taking some data. You guys will see right now it's still filling out the fuel pump control module stuff. So let's go EQ air. Actually, we'll do short term versus the. So you can kind of see where I'm at. Definitely looking rich down low. All right, so just like in other videos, I'm not trying to make this video a whole bunch on the tuning the VE table. I've showed you guys in so many videos now, but I'm gonna go ahead on and rough in some changes right here on the V side of things, and then we're gonna keep going. We're gonna also need to scale the cylinder air mass on timing, and I need to make sure, because obviously right now we're on NA timing as well. So we'll go in and build a good timing table for boost. So I'm gonna go ahead on and rough in this V table, and then we'll start working on the timing table. Change of plans. We're gonna tune this thing open loop using EQ Air. I've showed you guys a lot of the short-term field trim, like closed loop tuning, long-term field trim stuff. I've showed you guys that. Again, that's like more like the entry-level way of getting into tuning. That's how I think Goat Rope teaches a lot of people. Let's go into open loop. So as I've showed you guys before, to go into open loop on a Gen 4 vehicle, you've got a fuel, oxygen sensors, O2 readiness test, and makes this a number. Like this was -40, so I made it 493. We're gonna load in this file. So we're gonna tune this truck in open loop, which is more of how I would do it. Like if I wasn't on camera, I would be sweeping through the VE table. I need to disconnect from the scanner. But I would be sweeping through the VE table using steady state on the dyno. So I'm not gonna show you steady state on the dyno because you probably don't have a dyno if you're watching this video. So what we're gonna do is I'm gonna show you how to do open loop V tuning, or how I would do it on the street. I've showed you some of this before. Let this tune file load in and then we'll get into that. All right, so truck's in open loop now. So I'm gonna go in and show you guys. I've had a couple guys email me about this. So if you wanna build an EQ Air versus VE table, all you gotta do, just like what we did earlier, we're gonna right click, go to graphs layout, and let's just build one. We're gonna add a table. Parameter, what this is gonna be, it's gonna be EQ Air. So you just type in EQ. You'll scroll down, you'll see where it says EQ Air. It's gonna be under the maths, and this is the HPtuners input. This is already there for you, so EQ Air. So we'll do that. We'll just type in versus VE. Column axis is obviously gonna be the column axis for our VE table. So we're gonna go under VE table, we're gonna right click, column axis, copy labels. It is manifold absolute pressure. So manifold, we'll just go to right here. It should give us a pop-up. So anytime you see these pop up, just, yes, sounds good. Let's go decimals. We'll leave it at 1. Cell hits required. Let's do 10. We're gonna copy in our column axis, row axis. We're going to do RPM. So right click, row axis, copy labels. RPM. Just gonna click this. It should give us the same pop-up, and it does. So we're gonna paste this in. Now what you guys can do is, if you want this thing to kind of alert you, or like when you're looking at your table, if you want it to alert you a color, you can just say high value. I don't know, we'll say high value would be lean. So let's say 20 is a high value. It's called low value a -20. And so let's make it red if it's lean. Let's just call it green for go if it's rich. And there's our table. So what we're gonna do, we're gonna put this truck into gear. Now you can do this on the street. Now again, this is not the steady state version. This is what I like to do if I'm street tuning, or like this being an automatic vehicle, I would probably do it this way even on the dyno, just because I don't want to generate a ton of heat in the transmission. But you guys can kind of see where it's at. Now keep in mind, this is raw data. So this data is not smooth. And so you're gonna have to kind of use your own discretion when you're doing this. So anyways, I'm in first gear. I'm gonna go ahead on and slowly increase RPM. And so this is good, because we're in first gear, this is gonna take care of our high RPM low load stuff. So we can carry this up as high as what we want. All right, so I use the space bar to stop the log. If you didn't see that in my tips videos. Some of you guys, you may want to go back to my older videos if you haven't seen some of them. I think I did like a video, it's like 7 tuning tips. Most of those tuning tips in that video are stuff that usually even like professional tuners don't know. So anyways, I'm gonna let the truck stay running. And so what we're gonna do is we're gonna kind of, this green's gonna be hard for y'all to see on video. Let's do like a light teal. Is that easier? Okay, yeah, there we go. All right, so what we're gonna do, it looks like we're, all right, let's do it this way. All right, so what we're gonna do is we're gonna copy. So from 1600 to 3400, you'll see this is all in one column. So we're just gonna copy this, go under 1600, and this is at, what manifold pressure? This is at 45 kPa. So we're gonna go 45 kPa at 1600. We're gonna right click, multiply by %, and we're just gonna go all the way back. Because again, traditionally the changes that you make at Lower loads is going to be the same at higher loads, so it's going to shape the table. All right, and then I'm going to go, basically all we're trying to do is we're just trying to get like a generic percentage to where we're taking like a big chunk out of it. So at 3,600, we'll start at 45 again, multiply by percent. And again, I'm doing it this way just to kind of keep my shape to where I'm happy with it. So you'll see that big chunk that we just took out right here. All right, and then what we're gonna do is, well, it's saying 10%, so let's just go 10% from 60 down right here. Actually, let's do this as 10%. So times 0.9, and let's just interpolate vertically on this one. And you'll see where that shape is. And then it says 15%, so let's just do a 0.85 multi here. Now again, I haven't shut the vehicle off, and so let's go ahead on and restart the scanner, and we're going to do second gear. Now second gear should get us a little bit higher of a load, and I'm just going to kind of sweep all the way up. All right, that was starting to go a little bit lean. I wasn't real happy about that. So we're stopping the log. I'm still not going to shut the truck off. All right, so what I'm going to do, let's say, well, this data right here is probably not going to be super accurate. This will probably be more so in the ballpark. So let's say it, what do we want to do? All right, let's do 2,400, 3,200, 60. 2,400, 3,200, 60. And what I do want to do is where we had that little bit of an outlier, let's interpolate that one out. So 26 to 3. Yeah, 26 to 3. All right, so then what I'm going to do is I'm just going to bring this over, and I'll just bring this down. And you guys will see that chunk where we're at right there. And then we're just going to go down. So we're going to start at, let's do 3,600 at 55. All right, we're going to interpolate that. All right, so let's go, let's say 17% right here. And let's just say 17, 7. Now again, you guys may be thinking, oh, this is crazy. This is not turning out the way we would have expected. Well, that's because we're not even close to being done yet. So what I'm going to do is I'm going to kind of shape this table up without even shutting the truck off. I'm going to get some of this data going, and then we're going to smooth the table out, and it's just going to give us like a big, it's going to rough us in pretty fast. So, all right, so let's go down. Let's go and go into third gear. All right, so truck's in third gear. I'm actually going to stop the scanner. I'm going to start it right now, and let's roll into this throttle a little bit heavier. All right, so we're too lean. So all right, so now we're actually gonna have to flash this truck. So we're gonna stop the truck, and we're gonna shut it off. And let's go ahead on it. So 16%. So we're 16% at 80, 24. So 80, 24. I'm just gonna take and just add 16%. Better yet, let's just do it for this whole, let's do all of it, like just like that. All right, then what I'm gonna do is I'm gonna grab 55. We're gonna go to 80. All right, so there's that. So you see it kind of looks funny right now. And then what I wanna do is I wanna go ahead on. We're gonna click smooth a couple times, and it's gonna shape us kind of more into a good table. Now, more than likely, this is shaping up this way because I probably forgot to flip a switch when I was on video. So as I'm doing this stuff, I'm gonna look at this and I'm gonna be like, man, something's not right about this. I think I already know. So anyways, that's where our table's at right now. I'm going to copy this, load this into our open table. I'm gonna load this into our DoD table. And I'm gonna go to that switch that I probably forgot to flip. So we're gonna go under operating system. And yep, speed density air model, calc not returning to normal. We need to apply this. Manifold vacuum, this is a boost patch to actually allow injector flow rate to factor in boost. We're gonna apply that. So, and obviously before we go into heavier loads, since we're gonna start that, we need to go in and build a good timing table for this thing. So this is the table that I've got right now because this was the NA timing table that I had in the truck. I don't do what GM does a lot of times where I'll make this all the same number. Usually I will scale it down for air mass. This truck right here, natural aspirated, would have been in the probably 0.8 grams per cylinder air mass range. This right here looks like a pretty solid number, 23, because again, we're on the high octane table. This truck probably wouldn't have liked all of this, but it could have potentially learned up to it. So what I like to do is I like to rescale cylinder air mass, but I don't do that until I know how much air mass this truck's gonna move. Now this truck, I don't know how much boost this thing's gonna make. It may make 6 pounds, it may make 7. So we may not even surpass the 1.36 grams per cylinder air mass. So what I'm gonna do is I'm just gonna copy my 0.80 row. This is where I had it natural aspirated. And I'm gonna paste it into 1.36. And then what I'm gonna do is I'm gonna subtract 8 degrees from it. It should be a pretty good starting point right there. So again, we're not going full throttle just yet, but I went ahead on and I interpolated it down. So that way timing comes out with air mass. A lot of guys try to get super particular about their timing tables, and because none of us are obviously gonna go through, or I feel like on stock ECU at least, most of us are not gonna go in and bracket each RPM and add timing until that cell is happy and keep going down. Most of us are not. Now, some of us may, and if you wanna do that, some guys, if you want to do that, you use the bi-directional controls on the scanner and you can actually type in your absolute spark. So you can be sitting here and you can actually use your bi-directional controls on the scanner and actually adjust timing and watch live torque on the dyno, and you can actually tune every single cell. I just don't recommend that because of all the heat and everything else. And again, this engine is a factory 6.2 engine. So the factory ignition timing is going to be somewhat in the ballpark as it is. So we don't have to reinvent the wheel necessarily. So anyways, this is what I'm gonna start off with. And then what I do is because we're on speed density, for right now, I'm gonna copy this directly into the low octane table. And then I will build the low octane table after the truck's been calibrated. So I'm gonna go ahead on and load this in, and then we'll actually start getting into more the moderate to higher load stuff. So new timing table is loaded in, corrected VE table is loaded in. Truck should be a whole lot closer right now. Now, I want you guys to understand that if you've screenshotted or looked at the timing table that I have in this truck, also understand that I have other multipliers. I like to utilize essentially the factory intake temp tables, especially on pump gas. So what may look like high timing to some, you may be missing out on one of my multipliers. What may look like low timing for some, you may also be missing one of my multipliers. So when I show you guys this stuff, that's one of the reasons why I don't mind showing you, is because you don't actually know the exact values. Now, if you want to use that table for reference, you're more than welcome to, but just know that I still manipulate all the factory modifiers. I don't just zero shit out. So anyway, so let's go ahead on and get this thing rolling some more. We're gonna go right back into third gear. Since we just flashed it, there is gonna be a good chance that the open loop fueling that we're seeing right now isn't gonna be a final value. So I'm gonna just kind of let the truck run just for a second. Some guys have emailed me, they saw in other videos where I mentioned a rich after flash condition, and they emailed me, again, it's just trying to help. You know, they were like, you know, hey, you gotta zero out your injector temp versus offset table. It's like, yes, guys, I get all that stuff. Like, I've been doing this for a while, and I appreciate your attempt to help. But I want you to know that on Gen 4, especially Gen 4, Gen 5, rich after flash conditions, even if you zero out the injector temp versus offset table, it doesn't cure rich after flash. So anyways, I'm just kind of letting the truck run. But we should be good enough where I should be able to get somewhat accurate data on third gear. So I'm just going to go ahead on. We're going to go to probably 3/4 throttle or so. All right, so we're still lean. Now, as of right now, it is showing up as lean. It also could be a misfire. I think as of right now, I think I'm still lean. So we're just going to keep adding fuel. All right, guys, something is going on. I don't know if y'all caught that, but my injector duty cycle calculating through the roof. I don't know why. I just have a scanner issue on that last data log. Let's try this again. I haven't made any changes. Now injector duty cycle looks okay. Short-term fuel trim's not showing negative 100. I think it's just wigging out. Let's try that again. Get it in the third. Yep, we're just lean. That's cool. And obviously, again, I'm showing you guys how to build one from scratch. I've tuned hundreds of ProCharged trucks. I probably have at least 30 V tables that would probably be almost exactly what this truck needs, but I'm showing you guys as to how to just do this on your own. So I hope you guys understand that. All right, so we're gonna go back and we're gonna go to 290 from 2600. Let's just add 13%. It's kind of starting to get into a ballpark of where it's starting to look weird. 16 from 3200 down. Interpolate. See where that's at. So we're gonna go from 50 to 90. Interpolate. Smooth it out a little bit. We're gonna load this in and do it again. All right, so obviously our end goal is gonna be to develop our VE table. Now, I want you guys to always start off on VE tables. When it comes to tuning, especially Gen 4, Gen 5 stuff, start off on VE, because you can actually calculate your mass airflow sensor curve at the same time of you tuning your VE table. And I will show you guys, I may show you in this video, maybe the next video, but I'll show you guys how to do that. All right, so I'm gonna go on, let's go up like maybe 3/4 throttle or so. I actually heard some popping, almost like a misfire. Actually, I'm gonna keep the truck going. Let's, I'm just gonna go in and lay into it. Truck seems somewhat happy right there. All right, so I'm gonna lock this thing into 3rd gear and get the converter to hold. And let's go and get some wideband data at wide open throttle. If you heard that where it's kicking out, that's one of those tables that I've showed you guys before that I'll need to make an adjustment on. Mother. I know what the problem is. I know what the problem is. Or I know what one of my problems is. And this is stuff that, again, this is just happening because I'm on video, but for reference, I'm gonna show you, all right? So I had the base file in this truck already set up for the CTS-V map sensor. When I moved over to the 2-bar map sensor, some of you guys may have caught it in the video because I've been showing this screen the whole time. 2-bar operating system, it changes the map sensor scaling. I knew that, and I meant to say that in the video as we were going through the steps, but then like a freaking, you know, like ADHD person, just squirrel, you know, all of a sudden is like, I started to move on to other steps and miss this one. Because I'm sitting here, as I'm going through this data log, I'm like, no, we should be way over 91 kPa right now. That's why. So pretty much everything we just did was incorrect. And that's probably also the reason why the V table had to get changed as much as it did. So now that you guys have seen that, we're gonna leave the V table exactly the same. We'll just go and turn this into a lesson. Let me just pull up the base file from this truck. Open, compare file. And you guys will see where I already had it scaled for the CTS-V, the red label. All right, so we're not gonna change anything but the map sensor scaling. Let's look at the difference it's gonna make on everything. And literally I started this video off with trying to explain to you guys to make sure that we had all our vitals. But it was my mistake. It was just, as I've told you guys when I'm making these videos, I don't have a list in front of me. Everything is, I'm just telling you as I'm doing it. And because I'm explaining it to you, I'm starting from scratch instead of just pulling up the base file that I already had. Because I mean, I'd already basically been done, to be honest. Like right now it's 2:44. I started this truck at like noon. Yeah, it'd basically be done right now if I wasn't making this video. But anyways, live and learn. So I'll show you guys. I mean, it's exactly what happens when tuning is. You'll work through something and then you figure out, shit, I had something else, you know, set up incorrectly. I've had customers to where injector data was incorrect. Like I would kind of glance at it and be like, okay, that's the right plug or whatever, because the customers told me injectors. When I start doing the tuning part of it, I'll notice that the V table is way off in left field or the map curve is off in left field compared to what it should be. Then I realized that injectors are wrong. And literally with the incorrect injector data, you have to start from scratch again. So as we're going through this V table, I'm sitting here thinking like, man, this V table should be a hell of a lot closer than what it is. That's the issue. So now let's see what it's got. So now we're way rich. I should have known. I should have known. I honestly should have caught it earlier. Live and learn. All right. Yeah, she's pretty pissed off actually. I'm just gonna get up in a third gear. Lock it in, and I'm just gonna lay into it since that's basically the exact same thing we just did. I mean, look at how pig rich it is. I mean, just pig rich. All right, well, literally map sensor data. I mean, you guys see. So again, this is stuff that wouldn't normally happen to me if I was tuning this truck like normal, but trying to make a video, help you guys out. Lost about an hour's worth of time, hour and a half. So, oh well. Anyways, process for fixing this is the same as what we went over. Obviously, I have to pull a shitload of fuel off this thing. So I'm gonna go ahead on and do that. I'll probably go ahead on and pull up one of my previous V tables in the background. Just that way I can try to keep this video going. But that was my mistake. And so just so you guys are aware, when you do select 2-bar operating system, it is gonna automatically change your map sensor values. So, and again, I knew that. And that was supposed to be part of this video, and it just happened in the video just later than what I wanted. So anyways, I'm gonna fix this stuff and I'll be right back. Also, before I forget, I told you guys I was gonna show you how to keep the torque converter in the truck from downshifting. Under trans, you go under general, and this command gear control limits just make this higher than what you're ever gonna achieve. So I'll do 7,200. All right, so anyways, got a good base file ready for this truck. Made sure V was correct, made sure commanded air fuel for boost was correct, like went over all that stuff. But I went over everything just to make sure it's good, because now that I know what my issue was, now we'll actually start to go up a little bit higher and higher in RPM and start getting actually in the boost. So because of that, we need to make sure that timing is safe, fueling is safe, like everything needs to be safe for the truck to do, not necessarily a full pull, but a pull that's longer than what we've already done. So tune file is loaded in now with a V table that should be closer to what this truck's gonna want. I also made that change to the transmission to where it won't downshift when I go to do a pull. And now again, in order to do that, you still have to use the bi-directional controls on the scanner to actually lock it into third gear or second gear, or whatever you're going to use, and then make sure the converter is locked. So anyways, again, this is a generic V table. It is from a truck with a different camshaft. This truck is actually a little bit rowdier of a camshaft than what most run with Prochargers in these trucks, but that's okay, because again, this is a stage 2 BTR LS3 V2 NA cam. So all right, anyway, so let's go ahead on and get us back up in the third gear. All right, and I'm gonna lock us into gear, lock the converter, and I'm gonna lay into it. All right, truck started to trend a little bit lean. Again, this truck has a different camshaft. And also this truck has a D1SC, and most of these guys will either do torque storms or they'll do P1SCs. So a little bit different of a scenario. So anyways, what we're gonna do is we're gonna go ahead on and finish up our wide open throttle V table. And then I'm gonna basically take that and work my way back down into the low load stuff again. And yeah, so looking at this data, looks like we were a little bit rich, 3% rich. And it started to go a little bit lean up top. Nothing crazy, but just getting to the point where I needed to make an adjustment. So far, fuel pressure looks good. The fuel pump long-term trim still haven't cleared. So the fact that we're still, basically our target right now is gonna be 0.70 on this. So the fact that we're at 0.69 is cool. We're maintaining fuel pressure. And on this truck, I'm probably not gonna turn pressure up, because it's got a good size injector. It's got an 80-pound injector on pump gas, and that's a lot of injector for pump gas. So I'm just gonna leave the factory fuel pressure settings alone as far as what it's gonna want up top. I just wanna make sure that the fuel pump control module knows the percentage of PWM we need to keep this 525 pump happy. So all I'm gonna do, we're just gonna go in the V table. I'm gonna add a little bit of fuel and we're just gonna keep working through this. All right, so V adjustments have been made. If you guys wanna see what my table looks like currently, this is where we're at. Obviously, as the ProCharger's coming in, engine's becoming more volumetric efficient, so, and the camshaft doing the same thing. Like I said, this is a big car camshaft. So we're gonna go back and do the same thing, third gear, and keep working this thing in. All right, so I'm gonna lay into it. So far, everything's looking pretty good. On a pull like that, where we start to actually build some boost fairly rapidly, I wanted to kind of slow everything down and be able to take a glance at how much boost we're actually making, where my timing value is right now. And also, it's looking like, honestly, this truck, I may end up doing this thing in second. This third gear, it's a long pull, but also, I mean, we're already at 99 miles an hour and we're only at 5,600 RPM. So we're at 139 kPa. If you guys haven't seen me do this, you go to Tools, Unit Conversion. We got to subtract atmospheric from it, so we're just gonna call it 39. And we're at 5.6 pounds. So to show you guys just kind of where I'm at on timing right this second, is 5.5 pounds of boost. We're only at 12.5 degrees of timing. Now you may wonder as to how that doesn't jive with the timing table that you saw earlier. And the reason being is because, like I said, I use the IET modifier from the factory because GM knows pretty damn well as to what these engines can and can't take with intake temp. So the intake temp, I mean, it's already pulling, I don't even know if I'm logging that on here. Yeah, it's pulling 1.2 degrees right there. So, and there very well could be other modifier, like a modifier for engine coolant temp. 189 right now, so it should be 0. But anyways, that's how all this stuff works. So as the intake temp comes up, obviously it's gonna pull more timing out. But so I'm pretty soft on timing right now. Also, I did, when I was moving changes over from like a base file that I did activate the low octane table again. So it also may be somewhere between low octane and high octane. I don't know if I'm logging knock learn modifier on here right now. I am, knock learn factor is 0. Okay, so it's on high octane right now. So let's go high octane, go down to the bottom. Yeah, that's about right. 5,600 RPM, 13.5 degrees, minus 1.2. Yep, pretty much right where we're at. Okay. All right, cool. I'm gonna work through the V table again. We've got much better data now, and I'm not terribly far off now. You guys will see, obviously this is percentage off. Again, ignore this. This is gonna be a transport delay from the time that the wideband sees it. Basically from the time that I'll stomp it to the time that the wideband sees it, I ignore this, but this is valid, and it's valid all the way down. So you'll see that we're pretty close, touch lean or so up top. But I'm gonna keep working through this, and then we're gonna keep going. All right, we're gonna go again. This time I'm gonna do second gear pull. Again, it's just seems like such a long pull. This truck, where it doesn't make a ton of boost, is not the happiest with the load that this is like. So again, this dyno is really good at simulating load. So you can imagine if you were doing, say, like a 30 roll or a 40 roll in third, how long it's gonna take you to get to 100+ miles an hour. Like, it takes a while. Actually, I did it. Let's go down second. All right, so we're second gear. It may spin, but I just want some data that's higher up in RPM. It spun. All right, we're gonna have to go to third. It is what it is. I mean, intake temps look good, everything looks good, so let's go and roll in a third. We were pretty close on fueling. I did start to feel a little bit of harmonics in the drive line. We got up to 111. I usually don't like to go above 108 or 109. Not the happiest about that, but I mean, so anyways, we ended up 151 kPa, 7.39 pounds. We're at 12 degrees, but the truck started to go a little bit lean also. So anyways, I'm gonna work on this V table some more, And then it's about time for power pulls on the dyno. All right, so going over the data log from that pull, yeah, the dyno's still in vehicle simulation mode right now, but I am noticing that we're over our 0.7 modifier or multiplier now. So we need to adjust the fuel pump control module. And so now we're also probably gonna be over, our commanded or desired fuel pressure at that instantaneous fuel flow. So what we're gonna do is we're gonna go under max desired pressure. And it was pretty much maxed out. Yeah, 408 pound per hour. In pound per hour. And so yeah, so it's actually asking for like 40 something psi of fuel pressure right now, and we want more than that. So I'm going to make an adjustment here. Let's just so the factory, what I'm going to do is, because this is the factory table and this is what the factory wanted, I'm assuming they wanted it like this for a specific reason. So I'm just going to add the boost in kPa over this value. So let's go down to 381. Or well, let's go to max. Okay, so we'll say 51. So let's add 51 kPa to this. Let's just go like right in the middle. Let's say right here, 282. We're at 129, so 282. Try like 30. Let's see how this lays out. Okay. Better yet, let's just go from about right here. Let's go from 154.8 over. We'll just leave like that. That should give us, yeah, we'll stick with that. And then what I'm going to do is open loop DC. We're going to add our 6% here. Now again, I got that 6% because when we were up top right here, that we know that with our long-term pump trims being at 1.3, this should be at 0.7, and it's not, it's at 0.76, so it's adding 6%. And so we're going to check our table. Okay, yeah, so I'm just going to interpolate down from like right here. So I'll just have that little bit of a flare. Let's start doing a power pull. I'll turn the dyno on, like on actual power curve, and we'll see what this thing can do. So tune 5 loaded in, dyno is set up for a 3,000 to 6,500 pull. Haven't adjusted timing, haven't adjusted anything else. We've just got VE. I've just got EQ commanded where I'm happy with it. Get the fuel pump control module adjusted. So let's go on and do a rip. So again, we're gonna do third gear. I'm gonna do no eddy brake though, so it's just gonna be inertia only. And again, I don't tune inertia only, but I will do it for a power pull just because of, I just don't want that long of a pull on this truck in third gear. So again, ignore wideband down low. I've got to go back and redo all that stuff. So, all right, let's go and do a rip. Everything looked pretty good. Truck started to trend just a little bit lean up top. Nothing concerning. Obviously at this timing level, I'm not sweating it. So let's see what kind of power it made. All right, so it's going to be kind of hard to see. This TV is starting to go bad on this dyno. We got 519.4 horsepower for 56.4 foot-pounds of torque. Now again, that's low timing obviously, and that's 3,000, 6,500. We'll see that it looks like the curve, it looks like it hasn't even started to lay over yet. Let's pull up trace. Yeah, this TV is getting bad. This just started happening once we get the power surges. Those power surges are what took out the old dyno computer also. So force identical scales. Let's go to 550. And yeah, see, if you guys can tell, power curve looks pretty good. Let's get in the truck and look at the data again and turn it up some more. All right guys, so yeah, I just called the shop and they set up the pump the best the way they could, but basically this was kind of a test. Said something about the way the Venturi set up. You guys may know about it more so than me. I've never taken apart one of these buckets on this this style truck, but this is about where a factory pump runs out on one of these. So it may be just a limitation of that pickup module. We're gonna increase on VE, which is going to falsify the airflow model some because the fuel pressure drop. I mean, luckily the truck understands, it does comprehend the injector flow rate. Hopefully I can keep enough fuel in this thing. So I'm gonna add some fuel to it and we'll throw a degree at it and we'll see how much power it picks up. All right, I'm gonna test a theory. I'm gonna put the fuel pump duty cycle back to stock. It almost makes me wonder if this 525 under boost, if it's draining the bucket so bad that then the ECU is trying to turn the fuel pump all the way up to 100% and it's just completely aerating. I don't know that for a fact, But I'm gonna just try to turn this open loop DC back down. Now again, normally I don't have this problem. I've never once had to do this, but it just makes me curious that if that's what this truck is doing, is if it's just sucking that bucket dry to the point that maybe I even need to do what I would have expected and actually reduce the duty cycle to this pump. I don't know. It's part of the tuning process though, is you guys see what I see. So you see that we're down to 36.5 PSI of fuel pressure. And obviously that's not good when we're asking for 59. When I added numbers to the V table, it's going to falsify the airflow model, which is why my calculated horsepower and torque is incorrect. So it just starts to throw everything off. I'm going to reduce the duty cycle to the pump back to factory and see if that helps it. And if it doesn't, I'm going to reduce it even more and just see if we can figure out how to keep the pressure that we need at the rail. I'm just going to try it. We're just trial and error at this point. All right, let's do another pull and hope for the best. All right, see what she does. Still going lean up top. Yeah, down to 35 PSI fuel pressure. Oh, and of course the truck shifted down to low octane. Why? Yeah, it's just pulling too much cylinder air mass because I'm falsifying the airflow model. So then cylinder air mass is getting to a point where it's starting to rip all the timing out of the truck. Okay. All right, so let's try another pull in this truck. Timing's back up to where it should have been on the last pull. This sucks about the whole fuel pump deal though. I honestly wasn't sure. I mean, they asked me if I'd ever dealt with a 525 in the tank, and it's like, on this specific truck, no. Like I've done a bunch on like the 0708s, but this truck has the fuel pump control module, and I haven't tried it on this specific truck before. And maybe there's a way of doing it. I should need to plug my wideband in. Maybe there's a way of doing it, but you know, a lot of you guys that watch my channel, you're more familiar on like what's the little cool tips and tricks that you can do mechanically with the truck. I don't pay attention to that stuff. I mean, I know about all the tips and tricks when it comes to tuning and setting an ECU up and, you know, tuning fuel pump control modules and things like that. But I honestly, in all the years I've tuned this new body style truck, I don't think I've ever done a 525 in the tank like this. So definitely worth a shot. Kind of irritated that it didn't work. So far it hasn't. Went ahead and turned up the voltage just like what I normally do on the alternator, like on the Camaros. We'll try that and see how it reacts with a little bit more voltage. Not sure if it's going to help it or if it's going to hurt it. Obviously the truck's still rich. I still haven't worked on the down low stuff. Let's do a pull, hope for the best. All the timing was still out of this thing. Fuel pressure still dropping. Everything's just as bad. All right, I'm gonna dig a little bit more. Hopefully I can figure out something. All right, so I found the timing issue. I thought it was gonna be a modifier, and I thought it was just where I was increasing cylinder air mass. Well, technically it was, but the actual issue is the transmission input is 664 foot-pounds of torque. And because of the fueling surpassing, because I was falsely inflating the fueling, it was falsely inflating the torque, and it actually got to the point where we actually hit a torque management limit. And so as I've told you guys before, I don't just blindly modify these torque management limits. So I only move one whenever I need to move one. And so that's the timing issue. That's why we're down to 8.1, because I went ahead on and just made the low octane table the same as the high octane table. And so this thing should have been seeing somewhere around 13.5 to 14, depending on intake temp. Obviously IAT would have pulled some out. So here's what my IAT table looks like right now. So you'll see we were at 81 degrees, so it hadn't really started to pull too much IAT advance out. We were at basically 1 degree out. Yeah, we hit a torque limit. So that's how you identify a torque limit. And so now I'm going to modify the torque limit, get that one specific one out of our way, and then we do another hit. Fuel pressure's still dropping though. Like basically what I'm doing right now is almost a waste of time because I'm gonna have to short shift this truck until the fuel system gets resolved. Which this truck isn't a race truck, this is like a cruiser kind of truck. He'd probably be cool with it shifting like 6,000, but this camshaft, it really should be shifting at like 65, 6,600. So it is what it is. All right guys, so kind of just gonna do, I guess I'm just gonna do my final attempt. What I did was I went ahead on and reduced the voltage. I reduced the voltage at the fuel pump module down to more of like what I would expect to have to, since the pump is like twice as big as factory. I have no idea if this is gonna work. Like I really don't. I mean, you can see right now it's adding like 70% to the fuel pump trims. But I'm just curious if I'm fighting the PID on the fuel pump control module is what I'm curious about. So yeah, I don't know. I'm just gonna lock it in gear, and I may not get a full pull out of it. I'm just gonna watch fuel pressure. All right. As you guys can see, though, timing is definitely back in after I moved the torque limiter up and out of the way. So fuel pressure, it didn't help. I mean, I always tend to follow the data, so this is the first time that I'm completely opposing the data on what I'm thinking that the pump wants. But as you guys see, it ended up to where, so basically what this is doing is it's telling me it's adding 41% DC there, and then the additional 30% from the long term there. And even though injector duty cycle is at 78%, as you guys have seen, doesn't matter what I put on the V table, it just, the fuel pressure is just not there. So I guess we're just at basically a power limit for maybe this bucket. Maybe it's the bucket itself. But anyways, let's get out and see if this thing picked up any power on the little bit extra timing it had that pull. All right, so as expected, it picked up good power. 548.7 horsepower, 462.3 foot-pounds of torque. But again, guys, we're out of fuel pressure, so I'm gonna have to have this thing shift way before this. So it is gonna take some power away from the customer. But the good thing is he'll still be able to enjoy his truck, you know, during the time that whatever they got to do, whatever they got to do to fix the fueling. All right, guys, so we're just gonna call it done on power for right now. The truck is still safe. I mean, really, it's still safe in general, but I'm just gonna have it shift a little bit sooner. So, and then I've also got to build the MAF curve. So basically, actually, let me just shut this truck off. All right, so essentially what you want to do is when you're tuning speed density on one of these, if you want to kind of get an idea of where you're at on the MAF, you can actually build a table that is Dyno versus MAF. And so again, since we're in speed density, Dyno is going to be based off of speed density. And you can literally just have a table to where you just go to graphs layout, go to Dyno versus MAF. Your parameter will be dynamic airflow. And then column axis will be mass airflow sensor as far as frequency goes. Unit will be hertz, and then you'll put in input your values from your tune. And then as you drive the truck, if the fuel trims and everything are close, and you basically get speed density completely dialed, you can literally just drive around and it'll fill in your MAF table as well. And that way you're not having to start from scratch on a MAF curve as well. So what we know of right now is that at, we'll say, at 12,374 hertz, our MAF table should have a 670.95 grams per second unit in there. And that is actually even factoring in the fuel pressure drop that I'd already baked into the airflow table for VE. So yeah, it makes it pretty simple. So I had that in my members only videos, which again, I have members only link down below. I am going to start adding more and more stuff to the members only stuff, but I'm also, where the videos, it's almost a little bit harder sometimes for me to do the members only videos. I'm going to start to incorporate other attributes to the members only stuff, like as far as me helping you guys, like emailing you some like I said earlier in the video, like the channel config, or just emailing you other little tips and tricks that will be more like personalized. So I'm going to start to incorporate some of that as well, because it's honestly easier for me to email 100 people than it is for me to make a full video and edit it and then sit and wait for it to upload. So the videos are still going to be coming, but that's honestly the whole reason why I haven't done the members only videos as much as I had, is just for that reason. It just comes down to time. So anyways, I'm going to go ahead on and develop this MAF curve, and we're going to drive the truck a little bit on the dyno. All right, so I want some of you guys to understand why I really am not a fan of running mass airflow sensor with this ProCharger style vehicle. That is really just because, like right now, look at how turbulent our airflow is coming across the MAF. See how much it's moving, like at that specific frequency. So, I mean, there's a couple ways that you can kind of tune around this, but for the most part, it's not the easiest to tune around. So what I like to do in this application is, since we're running into an issue where the MAF is going to be kind of turbulent, I'm just going to run this thing in speed density, but the MAF curve is going to be dialed in as well. So I'm going to go ahead on and drive this thing a little bit. If you're wondering what that flashing light was, I'm old, so my phone has to strobe at me whenever I get a notification. It's part of being old. So right now you'll see that we're kind of keeping an eye on fuel trims. They're somewhat in the ballpark. And at the same time as we're doing this, so keep in mind, dynamic air is your airflow calculation after closed loop fueling calculations. So this is actually going to be correct. So whatever values we end up on dyno air here, when we put it in the correct spot of frequency, it's going to make our MAF curve dead on accurate to our whatever our speed density table is. Just like that. And I'll just show you super quick. It's just as simple as copying all, which again, if you don't know how to do that, you just click up here and it'll copy everything. Like, you click up here and it'll highlight everything. You right click, copy, and then we're just going to right click, paste, and you'll see our curve starting to develop. So you can literally just take this and just kind of smooth it a little bit. Let's see. And due to the turbulent airflow, it's not going to be as smooth as what we could ask for. So I just smoothed it a little bit more. And I'll smooth a little bit down here. And that's going to get us in the ballpark. So I'm just going to work on our MAF curve a little bit more. But realistically, that's probably going to be it for this truck due to the fuel pressure issue. But for the most part, I'm not 100% happy with it just yet. So I'm going to dial it in a little bit off camera and just make sure that everything is good, because obviously I want to give a professional result to my customers. So I'm going to make sure everything else is good, but I've kind of walked you guys through some of just the basics of really the stuff that I showed you today is the stuff that a lot of tuners get tripped up with. So anyways, guys, hope you enjoyed this video. I'm going to go on and just have this as one video since we didn't get to do all the cool stuff that I wanted to do. So this will be a single video. So anyways, I'm going to work on, I've got, just so you guys are aware if you're still with me, I've got the 5th gen Camaros I got to finish up this week. I have a red 6-liter swapped Gen 3 Silverado. You guys are probably going to enjoy that as well. So if you're not already subscribed, please do. Again, if you want to check out members only stuff, or if you want me to be able just to email you certain things like the channel config and things like that, members only link is going to be in the description. I also have in the description HPtuners device, a good wideband, and a Greg Banish tuning book. Oh, you guys are more than welcome to enjoy those as well. But I will see you in the next video.